Okay, it's about the time. It's about the time. Okay. Before you do the presentation, okay, I like to answer Andy's question. Okay. Let me show you my screen. Okay. Andy just asked that based on his result, using the 5% level, but the critical value will be different. Okay, let me show you again. Just Y variable. Okay, I think this if you do the PB, PC, or YD, they're all the same. We do have the same situation. Okay, let me show you the Y first. All right. If we want to do the unit root test, and we say that the critical value will be different, depends on the sample size and the different version. Okay, let me just start it with the one Andy shows that based on his test, okay, he's using only the intercept, means the version of 12.28. Okay, then usually the augmented Dickey-Fuller test, we need to include those length, okay, and we're using AIC, okay. Okay, if you start with 0, means there's no lag. Okay, if we started with 1, means we do have 1 lag. Okay, so if I started with 0, okay, so augmented Dickey-Fuller test without the lag. Okay, look at this one. If we don't have lag, I would like to say that observations using in this test, if you have the lag and without lag, is there any difference between the observations? Yes, it is. Okay, look at this one. If I use the 0, okay, look at this one. My 5% level critical value is negative 2.971853. Okay, well, see this one? Then, so remember this critical value, okay? Write it down if you will not forget. Okay, negative 2.971853 with no lags. Okay, then if I try the one with 1 lag, okay, so this is really augmented Dickey-Fuller test and the same version, 12.28. But since I have the lag 1, therefore my sample size changed. I mean, the sample size which can be used for the test, the observations will be different. Okay. So I look at the 5% critical value. It's turned out to be negative 2.976263, which is different from the one with I have used no lags. And the difference between these two critical values is because of the sample size. All right. So do I answer your question?
Yes, bro. Yes,
Andy?
bro. Yes, bro. Yes, bro.
Andy,
Yes, bro.
do I answer your question?
Yes, yes. Thank you, bro.
Okay, so
Okay,
the
bro.
critical value, the different critical value, again, based on the different version and also the sample size. With lag and without lags will determine the number of sample size. Therefore, the critical value will be different. Okay?
Okay, bro.
Uh,
I will try.
does anybody, no, except Andy, do you have some questions, or do you understand what I'm trying to say? I think this morning, Rudolph, Andy really asked the good questions, and I like to show you again which the critical value based on the Dickey-Fuller test, which is tau test. Okay, the critical value will depends on the sample size and also the version of the Dickey-Fuller test were used, and also with or without lags will change the number of sample size, okay, used in this test. Therefore, the critical value changed. All right. Do I make it clear to everybody?
Yes,
Yes, bro.
yes.
Yeah, okay. Okay. All right. So let's go back to our presentation, okay? So now whose turn? Okay. Then I think all the PhD students finished, right? So let's go back to our master students. So it's Esther.
Uh, did I show my screen?
Okay, yeah.
Number 6, we need to do at a 5% Dickey-Fuller test for the following variables. So the first one is y variables. We can see this graph. I think it tells us it is non-stationary. The second math is a correlation function, and we can see the data results. I think it is close to the 1, so I think it is non-stationary.
Okay.
The third method is augmented Dickey-Fuller test. We can see the p-value is 0.192x, and this is my hypothesis. So I think the probability shows that we cannot reject the null hypothesis. So y variable is non-stationary.
Which versions do you use?
Which version you mean lake? The lake?
We have three versions.
Yes.
The first one is no constant, no trend. The second one is constant and trend. Constant only. The third one is constant and trend.
Yes.
Which versions do you use?
I think it's 3.
The third one, okay? Okay, you're using the third. Okay.
Yes. The second.
Esther, move down. Okay, let me use your examples to do some explanation. Okay, move down, move back to the first one. Okay, I like to everybody see this one. Okay, this is also the augmented Dickey-Fuller test for Y, and based on Esther's, she used the third version. Therefore, we have different version, and also Esther using 3 lags, right?
Yes.
Okay, so look at the critical value. What is the critical value here shows? Negative 2.812, which is really different from what I just showed you, right? I'm showing using the second version. And also I showed the one with no lag, the other one is one lag. And now Esther shows the third version with 3 lags.
Yes.
Again, different version and different sample size. Therefore, the critical value is different. All right. All right. Thank you. So go on.
The second variable is PC, and we also can see this graph. I think this graph shows it is non-stationary. The second method is autocorrelation function, and we see this one is close to 1. So I also think it is non-stationary. The third one is augmented decay test. And we can see the data result p-value is 0.5478. So I think the probability shows that we cannot reject the null hypothesis. So PC variable is still non-stationary.
Right.
The third one is PB variables. And we also can see this graph is still, I think it still is non-stationary. The second method, we can see the number on this. I think it is close to 1, so I think it is non-stationary. The third one is augmented decay test. We can see the data result p-value is 0.1185. So the probability shows that we cannot reject the null hypothesis. So PB variable is non-stationary. The finally variable is YD, and we can see this graph, it is non-stationary. The second method, autocorrelation function, we can see this number is close to 1, so I think it is non-stationary.
All right.
Finally one, augmented decay test. We can see the data result p-value is 0.76. I think the probability shows that we cannot reject the null hypothesis. So YD variable is non-stationary. That's all.
All right.
Okay,
thank you.
Ask one question.
Yes.
I know we have the T value and P value, but I don't know why. How can I see the T value is T test number how to use the Gradle to see them, because I see the e-views will told you 1%, 5%, 10% critical value, but in Gradle we can see that.
Oh, okay. You mean what is the level of this tau test according to the Gradles? Okay, look at this tau test critical test statistic, which is where is it?
Negative 1.6773.
This is a test statistic instead of critical value, right?
Oh yeah.
Okay, then you are just able to see the p-values. So I'm not sure how well they really didn't show the critical value approach. They're just showing the p-value approach.
Yes.
Okay. So the p-value here shows according to your test statistic. This p-values is the p-value of your test statistic. Okay. we know that we have two approach. One is called critical value approach. The other one is p-value approach. So what we have seen from the grados, they just show the p-value approach. So they really didn't show the critical value from the output.
Yes.
But in eViews, they show the p-values and also show the critical value approach. They have shown two approach, but from Grados, it just show p-values approach only.
Oh, thank you, teacher.
Okay. Okay. All right. Okay. So we didn't see any critical value here.
Professor,
right.
I have one question.
Yes.
I have seen that in the Easter's paper, and he said in the last one, she shows the Easter. Could you put your paper on it?
Yes, yes.
Can we show it again? So I want to know that because at the last part you have seen it is including no legs. I at at last time I think the professor have said that you can test the length of the leg, so the number will change. Right. I think it will.
Yeah.
I tested it until it is until 4. It will be stable. Could you explain this more, please?
Gloria, is your question say that according to Esther's analysis, she is doing the lag with 0.
Right. Is that
And
the
you like, and according to the lag with 0, and it shows that it is non-stationary. But you
right.
like me to show that with different lags, is there any possibilities that is go to the stationary, change to the stationary? Is
Oh,
this
no.
your questions?
I'm just saying that if it is 3 lakhs or 4 lakhs, I think it is different, right?
With the different lags, maybe the answer will be different. We need to try.
All right, thank you. But Professor, I think the result remain the same, right?
You mean result remain the same?
Yeah,
Well,
I mean,
if you try it,
still non-stationary.
still non-stationary. According to, let me see the graph. According to this is YD, right?
Right.
I would say that it is non-stationary. You know, look at also auto correlogram. Let's see the correlogram. If you look at autocorrelation numbers, coefficients, okay, it just, really turn up and down. So there really, there's no constant trend. There's no constant situations from this diagram. So no matter what, how many legs you're using, I'm still thinking that it is non-stationary.
Okay, so Professor, I think it is not much difference if you use 1 legs or 6 legs.
Oh, well, it will depends on the data. If our okay, if you look at this autocorrelation functions, if you drop it to 0, quickly, very quickly, maybe after 5 or something, then with the different legs, maybe if it drops to 5, then if you're using 8 legs, then the result will be different.
Right. Okay, thank you.
Yeah,
Professor,
you see, I'm trying to. Yes,
I
yes.
want to ask about Esther. Can you show the graph?
Excuse me.
Professor? No, I want to ask the graph.
Graph.
The graph, yeah.
You mean the graph? Okay, show the
This
graph.
one, Prof. According Professor, this is not stationary.
This is
How
what?
not non-stationary?
Non-stationary, because it's a trend up. It goes nowhere. It goes to, we don't know where it goes. It goes nowhere. What's the three characteristics of stationary?
What
If
I
you look
know,
at our,
yeah.
yeah, if we look at our textbook, page 395, there are three characteristics. One is the mean is constant over time.
Yeah.
So this one, the mean is not constant over time. It's already it's going on and on. It's trend up. Okay. Second, the variance of the variables is constant over time. The second one is the simple correlation coefficient between xt and t minus k depends on the length of the lag, but on no other variables. If these three conditions, all of them met, then we say it is stationary. So probably if you look at all these trend up variables, most of the time they are not stationary.
I see. Even though the mean only a little bit different, I mean the digit, it means still we can say this non-stationary.
Yeah, because the mean of the variables should be constant over time.
Okay, bro. Yeah, we have to check the mean first and then we see the grip. Okay, bro. Thank you, Esther. Thank you, Professor.
Okay, all right. Okay, let's go continue, okay? So it will be the Daniel. Daniel, it's your turn. Okay.
Okay. I did it very simple according to the what they're telling. So I just doing 5% of degree Fuller.
Okay.
So the first one is the p-value. We have the result is the p-value is like 0.17. So it's more than 5%. So it's non-stationary. And the second one, PC is also. And the third one is 0.055. So it's also more than 5%, but it may be stationary at 10%. And the last one is YD is 0.35, more than 5% also. So it's also not stationary. Actually, I have a question why I'm doing it. Like,
Yeah, okay.
Because like the last class you show us to do the detrending on evil but not on Gretel, so I don't know how to do it. And when we will need to detrending it, so if we do that, what happened to our data and what is the meaning of it?
Okay. When we say that the trend means, I think we can do it when we work on the regressions. Okay, instead of single variables. Okay, so I think after I go back to our examples about PCE and the PDI, then I will say it again. we will talk about that. I will explain it more, okay?
Okay, Prof.
Okay, all right, thank you. All right, then, it's Linda.
Hey,
All right, Linda.
wait a minute. Let me show my screen. Can you see my screen?
Yes, okay. Would you make it a little bit larger?
Okay.
A little bit larger. Oh, okay, thank you very much.
Okay, in the first part, y variable, I think we can see this picture is equal to 1, so I think it's now now stationary. And we can see the plot, and we can also see that we can also think that this is a now stationary. And in the decay forward test, and we have the p-value 0.1769, and I just do the null hypothesis compared with 0.05, and we can see that we cannot reject the null hypothesis. So we can know that y variable is non-stationary. And the PC, we also can see the picture 0.7, and this close the 1, 2. So we can see that this is a non-stationary, and we can see this picture, this plot. They also show us PC variable is a non-stationary, and I do the decay forward test for PC, and the p-value is 0.5478. And the null hypothesis showed us we cannot reject the null hypothesis, so we can know that PC is a non-stationary. And in the PB, in this plot, 0.85, it also close the 1, so we can think that it is a non-stationary. And in this plot, we also can know that it is a non-stationary. And do a decay forward test again for PB, and the p-value is 0.05. And the result showed us we cannot reject a null hypothesis, so the PB is a non-stationary. And in the YD, we can know this picture on 1 is 0.89. It also close the 1, so this is a non-stationary. And in the plus, we also can know that it is a non-stationary. And I do the decay forward test, and the p-value is 0.32. And I do the null hypothesis, and the result show us this is non-stationary because we cannot reject the null hypothesis. And this is it.
Okay, all right, thank you. So Catherine, the last one.
Okay. Can you see my screen?
Yeah, yes, I do.
Okay. And
All right, thank you.
YT, we can see the graph. It shows us non-stationary, and the autocorrelation function for y is closer to 1, so it's non-stationary too. And here the p-value shows 0.19 28. It cannot reject a null hypothesis, and the Y is non-stationary. And the part B, also the graph, and autocorrection function for PC is 0.7957. And the p-value is 0.5478. It also cannot reject a null hypothesis, so it is non-stationary. And the graph for PB and the autocorrection function for PB, it shows us 0.8522 and is closer to 1, so it is not non-stationary too.
Okay.
And this one is for 0.1185.
Mm-hmm.
And it still cannot reject a null hypothesis and is also non-stationary too.
Mm-hmm.
And last one, the graph for YD.
Mm-hmm.
And autocorrection function for YD, it shows the number is 0.8955. And here, the p-value is 0.7615. And it still cannot reject the null hypothesis, and the YD is non-stationary too. So that is for my presentation.
Okay, thank you very much.
Thank you.
Thank you, everybody. Okay, and I think for this assignments, I really like all of you to know how to do the Dickey-Fuller test while you are trying all these variables. Then I think you have much more ideas and also more understand what we are doing for the Dickey-Fuller test and what do we mean by stationary, and without knowing this basic concept, I think it's hard to go on for the rest of the material we are going to cover for the rest of only 2 or 3 weeks. Okay, and I think the time series is complicated but also interesting. Okay, so I think I have done for our examples, which is using the PDI and PCE to do the regressions. And while we're doing this one, and I already show how to check with the variable of LMPDI and also the LMPCI, whether they're stationary or not, since we know that when we run the regression, if one of the basic assumption for doing this regression is all the variables should be stationary, okay? And that's why I think I show that individual LMPDI and LMPCI is non-stationary. Then since we know that both of them are non-stationary, if we run the regression and it turned out to be the spurious regression, okay, then how do we deal with that if we have this non-stationary variables? Okay, and one thing, so I like to go back to answer the questions what the Daniel asked. Okay, so let me go back to show my work. of the, no, this one, okay. Let me get my data. Where's my data? Well, there's no data from here. Let me see. Okay, so I think I need to go back and have my data first. Okay, the example I'm just showing is the I thought it's piece. Where is my PC? PCE and PC. Oh, here. Okay, this is what this is my examples for the. So I think I I have shown. Excuse me. Okay, I'd like to show this one first, okay? Since I already done the Dickey-Fuller test for individual Y variable and X variable, which is LMPCE and LMPDI, okay? If we run the regression with these non-stationary variables, what do we see? Okay, so this one, okay, open it, an equation. Okay, before we haven't learned any concept about stationarity, and we do the regressions, and we run the regression with LMPCE as Y variables and LMPDI as an X variables. So according to this output, what do you see? First of all, now we know that LMPCE and LMPDI are non-stationary. So maybe this regression, is spurious. And what do we know? Before we do the Dickey-Fuller test, okay? What's according to the output? Where did you see maybe this regression is spurious? Anybody knows? Okay, did you see this Durbin-Watson statistics, these numbers? What is these numbers tell us? Okay, the Durbin-Watson statistics was 0.3672. Raised the possibilities that this regression might be spurious. And I think we already see the graph of LMPCE and LMPDI. Okay, if I, I'm sorry. Open this again. Didn't we see this graph before? This is LMPCE and LMPDI. They are all trend up. Okay, the blue one, LMPCE. The red one is LMPDI. They're trend up. So both of them are a stochastic trend series. And And we say that with the Durbin-Walton statistics, and this is really suffers from first order autocorrelations. Okay, and the other science is that, you know, if we understand more about this meaning of the coefficient of LMPDI and LMPCE, this means what? This is personal disposable income. This is personal consumptions. Okay, and the coefficient, and since we take a log, so this coefficient means elasticity. Okay, with the meaning of elasticity means that if 1% increase by PDI will turn out to be 1.08, 68% increase by consumption. And it is greater than 1. Usually this coefficient is not over than 1. Means that you have $1, then you spend $1. That's maximum. Okay, if you increase by 1% of PDI, then you increase 1% of the PCE. I think that's pretty big. In which we have this 1.0868. Okay, and since we all see the trend up, okay, one way we can do to solve the problems is to add a trend variables. So what do we mean by trend variables? The trend variables is the variable which show the year, I mean the periods of the number. Okay, now this example is what we say the quarterly data. So let's look at the variables of the time. So if I open it, you know that we have 158 observations. The year, the variables, the values of the time variables means the first one to the last one. So we say that if we have the trend of variables, we may able to use the time as another X variables to detrend the situation between LMPCE and LMPDI. Okay, so let's do it, all right? So in other words, I'm going to run PCE as the Y, then LMPDI as an X, also with the time as another X variables, right? So that's open as an equation. I think I need to maybe I'll save this. I'm sorry. Maybe I'll save this one as an equation 1 first. Okay, then I can have this result to compare with later on. Okay, then let me also name this as a graph. Okay, group 1. Okay, let me do it. Then I can with this one. Okay, then I run this regression equation. Okay. All right, let's see the result with the other time plus a variable. Then let me compare this one with the one without. Okay, so what did you see? Okay, I think you can see that the coefficient reduced to 0.727, which is more reasonable. Okay, you see that? The coefficient reduced from 1.08 to 0.77. In other words, the trend, okay, they all trend up. It's because of maybe by inflation or something. So if I'm using time to detrend, then it will reduce the relationship between LMPCE with PDI. Okay, all right, and this coefficient turn back to the reasonable variables, means 1% increase by PDI will increase the PCE by 0.77%. Okay, but let's see the Durbin-Watson statistics. It's still very low. Okay, it means that with the trend variables, it reduced the relationship between the Y and X, but it really didn't solve the problems with the first order correlations. Okay, in other words, this, even I detrended the regression with this new with trend variables, then it didn't really reduce the possibility of spurious regression as before. It really reduced the problem compared with the one without the time X variables. Okay, in this case, okay, we need to do another one, which is what we say the co-integration. Okay, what do we mean by the co-integration? Okay, the co-integration means that let me see. Co-integration means that if we run the regressions, okay, and if we consider the residuals, okay, if the original X variables and Y variables are non-stationary, okay, after we consider their residuals, if the residuals turn out, we test if the residual turn out to be stationary, then we're saying that this regression is called co-integration equation. Okay, so in this situation, if I work with this one and the residuals, this is the residuals I already generated with using these models, right? So let me save it as an equation 2. And this equation, this residual, this is the latest residual we just generate. So I'm using another variable called V. Okay, this is the residuals using this regressions. If I test the unit root test from the residuals, and if this is I'm using, let me see. I'm using the unit root test, okay? And since I'm already detrained, okay? Let me just try that, maybe just intercept. Or let's start it with the none. Okay, then you know, I'm just trying error. Okay, let's see the Dickey-Fuller test from the lag 0 with the version, the first version. Okay, so what did you see? This is, what does this Dickey-Fuller test mean? This means the stationary is, this series is stationary, right? Okay, so why don't you go back and try this, try these variables, and let's check what the Dickey-Fuller test result from this regression. Okay, and I'm go on this example next week. And by the way, okay, I'm going to use another, I mean, the final class activities, which means the class activity 6. Okay, which one is pretty close to the example which I just going to show. Okay, for whatever we did the next week is exactly the same problems, but I'm using a different data set, different variables. Okay, so I maybe by the weekend, I will give you this new class assignments, which due June the 16th. Okay, then you will have you know, more times to work with. And also, since I already show how to do the Dickey-Fuller test, so this class assignments will also need to do the Dickey-Fuller test too, as well as the co-integration, which I will going to show next week, as well as some other important models, which I will to show next week. So by the time I finish next week's material, then you can do all the problems, which is our final class assignments. Okay? All right. Is that clear to all of you?
Yes.
Yes.
But for
Okay.
for the co-integration, you next week you more explain, right?
I haven't really explained yet. I just say that, you know, like these
Okay.
examples,
Yeah.
after I do the regression, I save the residuals. And after I save these residuals, then I done Dickey-Fuller test.
Yeah,
If this residual passed the Dickey-Fuller test, I mean, if this residual are stationary, then this is what we say co-integration.
Okay, bro.
This is what we say co-integration. So the assumption to do the co-integration is the original X variables and Y variables are non-stationary. Okay, although they are non-stationary, then after we do the co-integration, then if their residuals pass the Dickey-Fuller test, then even the original X and Y are non-stationary, then the result will not turn out to be spurious. I think this is the concept for co-integration.
Okay, bro.
Okay?
Okay, bro.
All
Thank
right.
you very much.
Maybe all of you can also read the books about co-integration from our chapter 12. Okay, I think in our textbook, we do some explanations of co-integrations, which from page 401, 401 and 402. I think this is the explanation for co-integration. Okay, then I will add some some more material next week too, besides co-integration. All right,
Okay, Prof.
is that clear?
Clear, Prof.
Okay, then I will give you this class activity number 6 by the weekend. Okay?
Okay,
Okay,
thank
Prof.
you, Prof.
Thank you
Okay.
very much.
All right. Let's stop here today.
Okay, Prof. Thank you, Prof. Bye-bye.
Thanks, bro.